Welcome once again. In this video, I want to help you to be able to analyze graphs and draw them. What do we have here? Well, in physics, sometimes they might ask you to draw graphs, and sometimes they might ask you to analyze the graphs. So here I put important few elements that will help you in drawing and analyzing your graph. And here I drew a graph for example to illustrate what I'm pointing out here. So if you look at the first element here, it says look out for the heading. Your heading will tell you something about the type of graph you are asked to draw or analyze. Sometimes they might say velocity versus time graph, which is here. Sometimes they might say momentum versus time graph. Sometimes they might say force versus mass graph, or force versus acceleration graph, or any other type of graph, what they usually do is that they put a y-axis first, acceleration, and then put x-axis secondly. So it's always y versus x here. What they mention first is on the y-axis, and what they mention after is on the x-axis. If they say acceleration versus time, then that means that acceleration is on the y-axis and time is on the x-axis. But here we have velocity, so this graph here is velocity versus time graph. So I am gonna cancel this one here, and I'm gonna say velocity versus time graph. This is the heading of the graph. It's always y versus x. So on the second element here, I said x and y labels with units. Of course, after drawing writing your heading, you have to label it on the y-axis with units. So we know that the units of velocity is meters per second, and we know that the units for time is seconds. So you must indicate the units after drawing your graph. So I think this noise might disturb us. Let me remove them. I will be back. I'm back. I think it's better now. Where were we? We were on the x and y labels with units. Of course, you have to label your y-axis with correct units and your x-axis with the correct units. And remember, this is a random graph. Not all graphs in physics are velocity time graph. You will meet with other types of graphs. Here I just took an example, and let's move on to C. So on C here is very important. The scale will affect the shape of your graph. So if your scale is not correct, then the shape of your graph will also be incorrect. So like here, let me bring it close. Like here, it's 1, 2, 3, 4, 5, and so on and so on. You cannot say 1, 3, 7, 9, and so on. Your scale must be correct. If here is 1, then that means here must be 2, 3, and so on and so on. If here is 2, then here must be 4, like 2, 4, 6, 8, 10, and so on and so on. And if here it's 10, this must be 10, 20, 30, 40, and so on and so on. Your scale must be correct. Same thing on the y-axis here. The scale is very important. You cannot say 40, 90, 1 million, and so on and so on. No. If you're working with millions, then write millions here. If you're working with thousands, then write thousands here. And another thing is the y-intercept. What does the y-intercept of a graph tell us? It tells us the initial amount of something. Like here, this true here tells us that the initial speed of whatever we are we are investigating here is true. So it tells us about the initial something, the y-intercept here. And what does the x-intercept tell us here? Well, the x-intercept, we do not have to worry much about it, because it can tell us two things. It can tell us about the maximum amount of something or the minimum amount of something, depending on the type of graph that we are given. Of course, we will talk about many graphs as we do this exercises here. And I want to talk about the last two important things here. What does the gradient of your graph tell you? You know that the gradient of a straight line is change in y over the change in x. So what is the gradient here? The gradient is let's choose 2 points. Let's choose this point and this point here, or let's choose this point here and this point here. So we will see the gradient. Let me not use m and write gradient. Gradient is equals to the change in velocity, which is the change in velocity, because it's the v final minus the v initial. And v final minus v initial, it gives us the change in velocity over the change in time here, because I will take the final time minus the initial time. It will give us the change in time. So what is change in velocity over change in time? Of course, it's acceleration. So the gradient of this line here will tell us about the acceleration of that object, or of that something that we are investigating. So if you remember from the equations of motion, we have this type of formula there. It says Vf is equals to V initial plus acceleration times change in time. If we move Vi to the left, I hope you can see there, is Vf minus Vi is equals to acceleration times change in time. If we divide both sides by change in time, we get that acceleration is Vf minus Vi over change in t. But what is Vf minus Vi? Of course, is change in velocity over change in time. So this is acceleration. So the acceleration of this, you can find the acceleration of this object by using the gradient formula there. And what the last thing here is the area under the graph. What does the area under the graph tells you? It tells you that well, let's look at this graph here. Sometimes you might find complicated graphs like this here. What you do is that you break that graph into rectangles and triangles, like here. We can break this graph here into triangles and rectangles, like here. Here we have a rectangle and here we have a triangle. And we can do the same here. We can do the same here. We have a triangle, and then here we have a rectangle. So what does the area? Let's talk about this rectangle here first. So we know that the area of a rectangle is length times breadth. Let me write it here. The area of a rectangle is length times breadth. What is our length? Our length is velocity. Let's say velocity. Our breadth here is time. So times time. But what is velocity times time? Remember from the grade 10 formula that distance traveled is equals to speed times time. So the area of here will tell us how far the object is going, or how far the object has gone. It tells us about the distance. So if they say calculate the distance or displacement, then you will use this the area of this graph here. And let's talk about the area of this triangle here. You know that the area of triangle, I hope you can follow along, is equals to half base times height is equals to half. What is our base? Of course, is time. What's our height? Of course, it's velocity. So what is time times velocity? Of course, is displacement. So we can use either of these two formulas here to find the displacement of an object. So analyzing and drawing graphs in physics is very much easy. You will see in the next video on how we do this here. So this is the end of this video. I will see you in the next one. Bye.